So it's calculus, first derivative test for graphing. We're looking for the increasing and decreasing intervals. So first thing we're going to do here is take y prime, right? Because we know when y prime is equal to 0 or non-differentiable, we have a critical value, don't we? So let's take a look at this for a second. So the first derivative, it's this thing, this function here times this one. So we're going to use the product rule. So we're just going to gather our pieces for the product rule. So f of x is equal to, yeah, just x. That makes it easy because then f prime at x is equal to 1. That works really nicely. With this one, with this piece right here, I'm just going to rewrite this function like this, that it's x times, and instead of writing square root, I'm going to take 16 minus x squared to the 1/2 power. Is that all right? So g of x is equal to the quantity 16 minus x squared to the 1/2 power. So the derivative of that, remember, we have to use the chain rule here, so we take the derivative of the outside, which is this 1/2 here times the quantity on the inside. 16 minus x squared. Then we have to decrement this exponent right here. So this goes to the negative 1/2 power times what? Yeah, exactly. Times the derivative of the inside, and the derivative of the inside is negative 2x. So negative 2x. So if I multiply this and this, I just get negative x. Everybody see that? I'm just going to put this in here as negative x. Now I build the product rule, which is f of x times g prime at x. So x times, and g prime at x is negative x times 16 minus x squared to the negative 1/2 power. Does that all make sense? Plus g of x, which is 16 minus x squared to the positive 1/2 power times f prime x, which is just 1, isn't it? This is where it gets to be kind of crappy looking. So y prime is equal to x times negative x is negative x squared, isn't it? This thing right here is a negative exponent, so it goes down to the bottom, right? So we get 16 minus x squared to the positive 1/2 power at the bottom, plus 16 minus x squared to the 1/2 power. If you look at these for a second, you see this is rational, this one's not. That is to say, one's a fraction, one's not. So to add fractions together, we have to get a common denominator, right? So this is the common denominator right here. This whole thing at the bottom down here is the common denominator, including this 1/2 power. So I'm just going to multiply this piece right here times that. 16 minus x squared to the 1/2 power over quantity 16 minus x squared to the 1/2 power. Look at this for a second. This is this rule, Gordy. X to the m times x to the n, right, is x to the m plus n. So it's this to the 1/2 times this to the 1/2, and 1/2 plus 1/2 is 1. So it's that whole thing to the first power. So when we clean it up, it ends up looking like this. Y prime is equal to this negative x squared right here. So this negative x squared right here, plus this plus sign is this plus sign is this plus sign. And remember, when we multiplied these two things together, the square root dropped, didn't it? So we got 16 minus x squared all over yeah, 16 minus x squared to the positive 1/2 power. Combine like terms, we have negative x squared here and negative x squared here. That gives us 16 minus 2x squared, doesn't it? Is that okay? All over 16 minus x squared to the 1/2 power. Remember, we're doing this derivative test, so we want it to equal 0. So I'm going to take this thing out and put 16 minus 2x squared is equal to 0, right? I'm going to factor this out a little bit and get 2 times 8 minus x squared is equal to 0. Now this is what gets really kind of weird for a second. I wonder if you can see this. 8 minus x squared equals 0. That's our factor, isn't it? So x squared equals 8. So what's the square root of, take square root here and square root here? You get x is equal to, what's the square root of 8? It is the square root of 8. It can be factored a little bit though. Get square root 2 times square root 4. Square root of 4 is 2, so it's plus or minus 2 square roots of 2. Can you see the interval now? It's just kind of weird. It's just kind of strange here. But this, I'm just going to set up the Cartesian plane here. And I'm just going to ask you to believe with me that this x value is what? Negative 2 square roots of 2. That this x value here is, yeah, positive 2 square roots of 2. Can you see the intervals now? And then you just take the intervals, take these intervals, take the test value, take sine of the test value, and then your conclusion. So what's the first interval? But less than negative 2 square roots of 2. That's from here out, isn't it? Now we're looking for the inside interval from here to here, which is less than, 2 square roots of 2. And then of course the last interval is this one over here from here out, isn't it? According to that's x is greater than 2 square roots of 2 and less than positive infinity. Actually, we have to look at this one for a second. We have to be careful here because look at this for a second. What can't... We have to look at this bottom piece for a second too, don't we? When does this denominator go to 0? Or 4 and negative 4. So this is 4 and this is negative 4. So we have to actually go back here to these intervals here. Right? And then fill in this math. And here, y prime is less than 0. I'm not going to make you do the whole thing. Y prime is greater than 0. Y prime is less than 0. So we have decreasing, increasing, decreasing.